As we get to the end of the calculus course, we start to shift our focus from more procedural process to more applications and looking at, now that we know how to derive things, we know how to integrate things, what are the applications in real life? And I think Delta Math does a really good job of putting those questions into different problem types to give you a chance to practice that. So they have a section that's called calculator context questions. So doing things in context of real life situations, things that will need a calculator because real life is messy. We have some messy numbers, and using the ability to derive and integrate depending on the situation. So here's this question. It is talking about the rate at which the snow depth is changing. So we have it's snowing, obviously, and it's changing in inches per week given by this Q function. One of the things I often think when I'm doing questions like this is we integrate a rate to accumulate. And that's something that just because it rhymes, it sticks in my head. If you integrate a rate, it will accumulate what happens over time. So that's what's going to happen with this one. If we integrate what's going on with this Q function over the interval 0 to 12, I'll be able to figure out how is that depth of snow changing over that time interval. And this reminds you that you are going to need a calculator and you are going to get answers that are decimal. We're going to round 3 places. So we need to grab our calculator. Actually, first I'm going to kind of write down a setup for this, and then I'm going to grab my calculator. So if we integrate this Q function, which I'm just going to generically write Q of t. If we integrate it from 0 to 12, it's going to give me the total amount of snow accumulation over that 12, or in terms of weeks, 12-week interval. Now, we do have to realize that we do start with a depth of 15. So whatever I get here, I'm going to have to add 15 to it. Usually they'll see the put 15 put in front because that was already on the ground to start with. So you're going to need to grab a calculator. And you're going to go to Math 9, which is going to set up your definite integral. So we're going from 0 to 12. Make sure your calculator is in radian mode. You will have a lot of trig, a lot of messy functions with these. So -6 sine of 0.07 t squared. I'm always going to enter it in terms of x's. X squared plus 2. Again, put the variable at the end. I'm always going to go with x's. Hit enter. So that's going to give me the total snow accumulation over that 12-week period. We do have to add a 15 to it because that's how much snow was on the ground to start with. So we get 21.87. It's going to round up to 872. So what we are doing is we're entering that number, 21.872. And then it's going to ask you what unit you're working with. Well, we are looking at snow accumulation, which is going to be in inches. And we're going to submit. So that's one type of context question you could see. See if I want to go through and do this one. I'm going to do the next one. Trying to find really specific ones. Okay, so here's an average value question. So this time they're giving you a function that is representing the rate at which people are entering a sports arena in people per hour. And it wants the average value of that, the function, on the interval 0 to 2. So you may remember or may not remember, average value is integral area divided by width. So average value is going to be the integral of this function that we want the average value of, going from 0 to 6 divided by the width of the interval. That is average value. We did that in chapter 4 when we talked about area. We usually did it with just average height, but this is actually going to do it with a function that has like a real life meaning. So again, I'm going to need to grab my calculator. I am going to Math 9. I'm going from 0 to 6. I am working with -62 sine of 0.13 x squared plus 86. And then I'm going to take that answer divided by 6. I am going to the nearest thousandth again, so 67.205. 67.205. Now we got to figure out the units. So it wants the average value of n. So let's look at what n is in terms of. N is people per hour. So it wants the average people per hour in that time period. So we are just averaging that unit. So average people per hour. Submit. It's giving you the average value of that function, and that function was in terms of people per hour. And then it'll kind of show you the work and how that all gets set up. There's one other type that I wanted to see if I could find one. Not that one. That's another average value. Okay, this will work. So this one is looking at the rate, again, snow, a lot of snow going on here. The rate that the snow is changing is this C function. And it tells you at time 0, we have 10 centimeters on the ground, and we want to figure out what the depth of snow will be at 6. I think this is actually pretty similar to one we already did, but it's still a good one. So again, we integrate to accumulate. So my boundaries are going to be 0 and 6. I often tell students it's what you know and what you need. I know what's happening at 0. I need to know what's happening at 6. If I integrate this C function, which is the rate that the snow is falling, that's going to give me my snow at 6. And I'm also going to have to add how much snow we started with. This one is very similar to one we already did, but that's okay. So we are going to Math 9 again, going from 0 to 6. We have 2 cosine 0.00, or not 0.0009 x squared plus 1. That's going to give me how much snow has fallen. We started off with 10 already there. So we're going to add that 10 on. So we get 20.236. So 20.236. And that is snow in centimeters. There we go. There's one type I'm looking for. No. This one actually tells you how to set it up, and it wants you to figure out what it represents. So I will mention it. The rate of change of your foxes is given by a D function, and we're integrating from 4 to 11, this D function, and then dividing it by the width of the interval. That's why the 1/7 is there. So this is actually your average rate of fox changing in the forest, because this is an average value function. We already did an average value, though. Yeah. This one's actually totally different, but I will show you this. So this one's actually asking you to derive a function. I don't know if I've shown you this on a calculator before. It's giving this function a that is water in a tank and wanting to figure out what happens at the derivative at 7. So it's like you're finding a slope. Now, you could do this by hand, but it's a tremendous pain. So let me show you how to do it on a calculator. So you're going to go to math, but this time instead of math 9, you're actually going to go to math 8. And that's going to evaluate a derivative at a particular value. So you're going to put whatever variable you want to work with. So I just want to work with x all the time. Type in your function. So 48 sine of 0.02 x squared. And we want to know what's happening at 7. So you're going to have to tell the calculator what is the function you want it to derive and what is the variable value you want to plug in. So when you do that, you get near 7.486. And it's going to want to know, what is this representing? So if A is the amount of water in the tank and we're deriving it, where when we derive something, we create a rate. So we create how that amount of water is changing. So I've got 7.486. And this is going to be how my gallons are changing over time. So this is going to be my gallons per minute, because again, it's a rate because we're deriving, just like a slope when we derive. And we get our answer. I think that for now we'll go with that. I'm gonna look and see. Maybe I'll make another short video if I find a good one. But this takes you through a lot of context problems, mainly integration. But as you just saw, there was a really good derivative one, and it shows you how we can use our calculator to do derivatives and integrals that are definite, having numeric values to get your answer faster.